is visible, sir. No issues.
Okay, so try this question and you can ask your doubt.
Sir, I've got answers. That's fine.
Okay,
Sir,
so tell me the equation what you wrote. Yeah.
sir, acceleration equations, sir.
No,
Sir, for the
just
linear motion of the center, you can say forces along x-axis will be ma, no, sir. Axis m and axis center mass.
and what are the forces along x-axis?
So for the capital F and the friction will be along.
Yes. Okay, capital F plus F is equal to ma. That you have written,
M.
right?
Yes, sir. Yes, sir.
Now second equation.
Sir, we can write about for the rotational motion, sir. Torque equals to I alpha. I'm writing, sir.
Okay, what is torque?
So the torque due to the force capital F will be
Just
minus F
directly
first.
equation. Read the complete equation that you have written.
Yes, sir. Sir, F minus F
Okay.
into A by R equals to half ma, sir.
F into A by R. What is A?
Sir, acceleration, sir. I'm saying.
Again, repeat the equation.
Sir, F in F. So capital F minus small f into
Okay.
R equals to
Okay.
half m into A, sir. We get for
Uh-huh.
rotation
Okay.
motion,
Okay.
sir.
Okay. Yes, so that is correct. That is correct.
From
This is the correct way to do it. Yes.
from solving, we can get the axis of C most easily.
Yes, you will get. Yes, you will get. What you are getting acceleration.
So 4f by 3m for acceleration of C,
Hmm.
sir.
That is the correct answer. 4F by 3M is the correct answer.
Yes, sir.
Okay. So that is correct. And if you want, you can solve this question or we can go to the next. So this is again same type of question. Only difference is that right now it is in inclined plane. Rolling, pure rolling on inclined plane. Same type of question, same process. Yeah, but the thing is little different because the what you have to find is little different in the second part. First part is same. Find the linear acceleration of the rigid body and force of friction. But think about the second part of the question that says what must be the minimum value of coefficient of friction so that the rigid body may roll without sliding. You can ask your doubts. Already FBD is drawn here.
So in that case, earlier film for which the body will be in pure rolling, we can say. No?
Are you there?
Hello, sir. I'm audible, sir.
Are you listening? Not listening?
Hello, sir. Am I audible, sir?
Okay, okay. Yes, you are audible.
Yes.
Try this question.
Yes, sir. So, man, we need to find the value of mu for which the body will be in pure rolling.
Yeah.
That's all. That
Yes.
is.
Minimum value of mu for minimum value of mu so that the body will be in pure rolling.
Yes.
You can just tell me the equation.
And first to define acceleration of rigid program force of friction. Hence, energy scientific and as a phase of statement and the rotation torque is due to friction F into R equals to I alpha. The friction equals to I alpha where R directly and K square. Look at rolling acceleration of center of mobility R alpha mg sin. Sir, the equation will be mg sin theta minus f equals to mg sir, and f r equals to I alpha, sir. By substituting friction in this equation and I equals to mk square, we can get the value of friction and the linear acceleration of body.
Okay, that is okay. Just tell me how you will find this minimum value of coefficient of. So here you have to understand that so that the body may roll without slipping. Without slipping, if the friction value will become lesser than this value, what will happen? Slipping will.
Then the body will slip, no, sir, we can say.
Then the body will slip. So it means that at this value, the body is about to slip but not slipping, right? It means that the friction force will reach its maximum value. Are you getting?
Yes, sir, it
Which
will be.
means that
Yes, sir.
friction should be less than or equal to mu s into n. So if you will put
Yes,
in
sir.
this condition, you will get the value of mu s minimum here. F you already calculated, just substitute in this equation, you'll get it. And n will be mg cos theta. Are you getting?
Yes, sir, I'm getting.
Yes, so like this you can do it. Okay, so you can try this question. Try this question. I hope question is visible.
Yes, sir, question is visible.
Are you getting the answer or not getting?
So 1 minute, sir, I'm reconnecting, sir.
Okay, okay,
It's showing that a picture has been stopped due to my network.
okay. So
1 minute.
rejoin. Okay.
Yes, sir, I'm rejoining. Kinetic energy is half IP omega square. IP momentum started to about this. Okay. General kinetic energy. The total kinetic energy or just translation kinetic energy difference?
Yeah, tell me.
So it's kinetic energy means only total kinetic energy or just kinetic energy to translation of body, sir.
What do you think? It should have both or it should have only. What do you think?
It should have both, sir.
So then calculate both
Yes, sir.
and prove that it is equal to this. But here I is not about the axis. I is about
Point
P.
P, sir.
You can ask your doubt.
Sir, I'm calculating, sir.
Okay.
Sir, I got half IP omega. Sir,
Sorry.
I got it. Can you this half IP omega square?
Okay. IP, how you got? By using which theorem? How you got IP omega square?
Sir, you know the IP will be MR square, no? So by using parallel
This,
theorem,
this
I
is
got it.
this is what is this? This is you are assuming this body
So
as a
I'm
range
assuming
at
disk I am assuming, sir.
you are assuming disk. Yeah. So that is you are saying it will be mr square about p, right?
Yes, sir. About P, sir. Sorry,
That
disk.
is wrong. That is wrong.
Yes.
Means mr square about x is passing through p and in the plane of the disk or perpendicular to plane of the disk. The axis is in the plane of the disk or perpendicular to the plane of the disk.
Sir, it's perpendicular to the. Okay. Sir, it's a perpendicular to the plane of disk.
So then it
Can
will be not be mr square.
not yes, sir.
So then how you are getting the answer?
So then this question is some part is missing also means with the shape
No,
of the body.
no,
No.
not missing. Nothing is missing. It is perfect. So
The
basically,
parallel
what you
IP
should do is that kinetic energy is equal to half mv square plus
half I omega square.
half I omega square. And
Yes,
this
sir.
I is about COM, no?
Yes, I have about center of mass and about
I
the
COM
axis.
omega square, right? But omega is how
Yes, sir.
much? Omega is how much? V by R.
Yes, sir. We cos R omega. V by R.
Then what we will write? Half I omega square. Omega is V by R. So I
V square
and
by.
V square by R square, right?
Yes, sir. And by substituting R, okay, sir.
Or you can do one thing. Keep it as half I omega square and write this as R square omega square because V is equal to R omega, right?
Yes, sir.
R square omega square. And now take half omega square common. If you take half omega square, what is left inside?
Sir, MR square plus I, sir. I plus MR. It will
Which
be
is
IP.
nothing but IP, which is
IP.
equal to IP.
Yes, sir.
Parallel axis theorem.
Yes, sir. P. Half IP
That's,
omega.
that is what you have to do. Okay, so there are many questions of this type. Keep solving, come with doubt. Keep solving these questions, come with your doubts, and you can also apply conservation of mechanical energy to a body which is rolling on inclined plane. Can we apply or we cannot apply? First of all, mechanical energy is conserved or not conserved. Suppose a cylinder or a sphere is rolling on an inclined surface, rolling down. Mechanical energy of this body will be conserved or not conserved while it is rolling down?
It
Tell me.
converts.
But friction is also there between the sphere and the inclined plane. Friction is also there. So it should be conserved or not conserved?
It should be not conserved, no, sir. Because
Why?
friction comes in non-conservative.
So what is law of conservation of mechanical energy? Does it say that if there is non-conservative force, then mechanical energy is not conserved?
No, sir.
So will it be conserved or not conserved?
It's according.
Friction is there. While it is rolling, friction is acting on it.
Friction is acting because we can apply, sir, conservation of energy.
So yeah. So why we can apply?
Because work done.
Tell me the
So
why
the
it
work
is
done by the
applicable even
friction
if
can be
friction
zero.
is there. Means what is the condition?
The work done by
Yeah.
so we can say work done by the friction can be zero. So in the case of
Why? Yeah. How it is zero? Work done by friction.
sir, because we should see the displacement of point of contact, no, sir. Friction. Sir,
It will be zero, but you have to explain.
sir, your voice is breaking, sir.
You have to explain. Yeah.
Sir, your voice is breaking. What, sir?
Which is the point of contact, right?
Yes, sir.
So friction is not doing any work because the point of contact is at
Rest we can say, no, sir.
rest.
In case of pure roller.
So now you understood any rolling or only pure rolling.
Sir, in the case of pure rolling only, we can apply, no, sir.
In pure rolling or any type of rolling. Tell me.
Sir, your voice is breaking, sir. Hello, sir. Am I audible,
Okay.
sir?
Yeah. Now is it clear? Yes, you are audible.
Sir, your voice is breaking, sir. Few words I can hear, sir.
You are audible. Am I audible now?
Yes, sir, now
Am
you
I
are audible.
audible or not audible?
Sir, now you are audible, sir, clearly.
Okay. So,
Now you are
okay. So
clearly.
I'm saying that if the body is not doing pure rolling, then mechanical energy is conserved or not conserved?
So then the material is not conserved, sir.
Okay. Yes. So it is only conserved for pure rolling because the point of contact
Pure
will be at
rolling
rest.
condition.
So there will be no work done by the friction. Yes. Now because mechanical energy is conserved, so loss of potential will be equal to gain of kinetic. But when we say gain
Kinetic
of
energy.
kinetic, there will be both the kinetic energy addition, right?
Yes, sir,
Translational plus
translation,
rotation. This is the
rotation.
equation. Yeah. After solving this equation, you will get ultimately this relationship between the velocity of a body rolling on the inclined plane. This you can directly remember as a formula also if you want, right? Or you can derive it quickly by applying conservation of mechanical energy. Now comes the condition of toppling. So for example, here you can see a block which is kept on a rough surface, and on the block some force is applied in horizontal direction, but the surface is rough, so there will be friction also in backward direction. Now here if you see that the force is applied at a height h, so in this case if you draw the free body diagram of the body, just see how many forces are acting. So one is this external force, one is mg, one is friction, one will be normal reaction, right?
Yes, sir.
Now the question is that if you apply a force, the body will slide. It is not necessary all the time. It depends on where you are applying the force. Maybe that the before sliding starts, the body actually starts rotating and it falls down. That is called as toppling, because these forces are producing torque also. Just calculate the torque produced by this external force about this point of contact here, about this edge here, edge of the block S. What is the torque due to the external force? About point S. Looking at the diagram, you can answer.
So, sir, also I'm not.
Can you see the diagram? Sorry.
Sir, can you zoom the diagram, sir?
Okay, 1 minute. Is it visible now? Diagram is visible?
So now I can see, sir.
Not visible. Okay.
So now I can see, sir. No issues. So now I can see, sir.
Okay. So, okay. So now what will be torque due to this external force about this edge of the body?
About the edge, sir. Can sir.
Hmm. Yes.
Sir, the effect it will be no, sir. Plus, sir.
Yeah. So F into H, right?
Yes, sir. F into H, sir. F top.
So because there is torque due to this force, so this torque will try to rotate the body like this.
Yes, sir. It will try to rotate, sir.
And if the body will start rotating, but then also calculate the torque due to mg about s. Torque due to mg will try to rotate it in this direction, right?
Yes, sir.
So if the external torque due to external force exceeds the torque due to mg, then only the body will start rotating.
Yes, sir. Then only the body will start rotating, sir.
Yeah. So then the body will start rotating, and it may topple and it may fall down. Okay. So that is the situation here, that body will topple if there is a net torque about the edge. So you can try with any question, then you will understand. So you can try with this question.
Sir, but the torque due to mg will be zero only, no, sir.
Why?
Then,
Torque due to
sir,
mg, why it will be zero? It will be
about the
mg into b by 2. Look at the diagram. Mg into b by 2 will be the torque due to mg About S we are calculating. About S.
Yes, sir. About S. Engine.
Okay, try this question. What will be talked due to friction about S?
Friction. So it will be zero. So the friction does not produce a charge. About S.
Yes, no torque. Yes, no torque. What about the what about the torque due to normal reaction about S? Torque due to normal reaction about S?
Sir, N and D B by 2 we can say this normally.
No, it will be also zero.
Sir, there will be two normal.
If this body will start rotating, what will be shape of this will come in this position like this, right?
Yes, sir.
Now, where is the contact between the floor and the block? At which point?
Test point on it will be the contact point. At test point only the contact will be. Sir, at point S1 the body will be in contact.
Are you there? Tell me.
So at point S1 the body will be in contact.
Yeah, so then normal reaction will pass through point
Yes. Yes,
S.
sir. Yes, sir. Yes, sir.
What will be talked due to normal reaction then about S? Zero. Are you getting it?
Zero, sir. Yes.
Because normal reaction will pass through S.
Yes, sir.
Yes. So normal reaction and friction in that situation will have no talk about S.
Sir, the voice is breaking.
You can ask your doubt. Question is visible to you, not visible.
Question is visible, sir.
Okay. Tell me, what is your problem?
Sir, 1 minute, sir.
Hmm.
Sir, screen stays stopped.
Screen is not visible.
Sir, not visible, sir. It's stopped, sir.
E- okay, 1 minute. I shared it again. Check it. Is it visible now?
Sir, again it's showing screen share stopped, sir.
Okay, 1 minute.